And just going, if you are a New York or New Jersey resident, you can earn continuing education credits for attending the full webinar. You just have to participate in the polls and complete the survey at the end of the webinar. We also have other webinars coming up. The next one is Advanced Post-Processing Techniques and Workbench. The other one is Generating Inflation Layers. That's meshing related for CFD. And then submodeling and ANSYS 14.5, different ways to do that. So you can always check us out online for e-learning webinars and get more information related to each one of those. So talking about ET, well, then it's called Application Customization Toolkit, but it's really just a new capability that came out in Workbench that allows you to build in your own features into the mechanical interface. So to customize that interface for your specific need. And those things could be, in terms of customization, really it's set up for pre- and post-processing, probably the main use, but those pre-processing conditions could be something like your own unique load, boundary condition, something that you want to put into mechanical interface that's not already there. So ACT allows you to do things like that. So you also want to just change, an element option or some solution setting or some minor setting that you know is in Classic and in Workbench GUI. So ACT will, aid you to do things like this. And you also have your own unique post-processing result item that shows up. So that's really the main focus, I would say. But you can also use ACT for accessing information in the mechanical interface, say node element numbers, access geometry, and different finite element information that you otherwise wouldn't be able to get to. And you can also use ACT to tie Workbench into a different solver. So those are the uses for ACT. At this point, ACT is a new ability that is only going to grow and expand upon, but where it is right now. So ACT provides you the hooks that are in the code to be able to link in what you would add into the code. So compile anything or use existing libraries. You can just attach your customization to what's already in mechanical. So if we let just all of what we're talking about here is that ACT put in these customizations, right? So you see all the buttons that are across the top toolbar here. These are all ACT extensions there. So these function just like any other that's already in mechanical. So it will look at that. And what can this do? Well, really it's set up to allow you to put something specific that you need into the code, right? So ANSYS is just a general purpose code, so it works for a wide class of problems, but it may not have your specific load or might have something very specific to what you do. Again, you know that that's something that's available in Classic, and you can use that capability in mechanical. So it allows you to do that, and really set up to kind of get the need for command blocks. So instead of using a command block, you can build your own button. It does exactly what that command block would do. This makes it easy to roll this extension to the whole company. Everyone's doing the same exact thing. They don't, no one has to, or type command block in. It's just basically a different functionality that's already there once it's set up. So ACT is really not a tool for scripting already existing features in mechanical. So you insert fixed boundary condition. That's something that's already in the GUI. It's not really set up to automate that type of a task. It's really more set up for you want some new features in mechanical. So a little around that. So now to know what AD is and what you do with it, let's just take a poll here. You should see the poll pop up on your screen. So main use for ACT, knowing what it can be used for. if you can submit your answers. Looks like we got half the participants have submitted, sir. Let's wait. Answers. I'll poll here in a minute. I'll close the poll. It looks like that's about it for those who are going to submit their response. So share the answers with you. So it would be your main use for ACT, and it looks like mainly either reusing APDL quiz or a new load or boundary condition. And I'll say the way that is set up with ACT is really they're sort of the same. You're essentially replacing either an APDL script, or your new load or boundary condition would be some type of APDL. So really kind of the same in terms of what would be required from you to do that, but different uses. So that's certainly the majority result quantity. So okay, it's good. No one wants to at least link or solve it as another capability. Great, thanks for just that. So we'll you can close that polling window if you'd like. We showed what the ACT extensions look like when they're installed. There's buttons on the toolbar. They could also be menus in the GUI. However you want to put that in, you can do either. But once extension's installed, then you click a button, and then that new feature gets inserted into the outline tree right here. So we see something called load on surface in this case. And then you can on that object just as if it was an already existing object mechanical, the details pane. So you select surfaces for this object, and there's also some different inputs that this will take. So everything looks exactly the same as, say, this fixed support boundary condition, right? You insert it the same way, you do the same thing. So it functions just like any other feature. So then, how do you setting this up or creating your own extension? Well, everything in the GUI, here the button, the icon that's attached to that, where this shows up in the outline tree and all the details that correspond to this, that's set up through an XML file. ANSYS does have a bunch of examples already out there that you can use to basically modify for your own purpose. So you don't have to really reinvent the wheel, but you're going to need to set up an XML file that's going to control what it looks like in the GUI. And the file handles the data that's inserted in the details. So then also a Python script that you need to do. So that way when you click the button or really, if we think about what we need to do here, this object that's in the outline tree, we put some data in here. But it doesn't really mean anything because this is something in the GUI. We really need to get this into ANSYS Classic, right? Just as a support boundary condition, you hit the solve button, that fixed support gets written out into the ds.dat file when you hit solve. So that's a process that goes on when you do that. So we need to do the same thing with this win load that we put on. We need to take this input data that we're providing mechanical and then feed that into the ds.dat file when we hit the solve. So that's what the Python script does. Way to examples for this, how to link that in. But when you hit solve, then it takes all these inputs, it grabs the faces, maybe creates a component from those, sets up some elements options or surface pressure in this case based on all these different values. So that's what we're doing. We're putting something into the GUI, but at the end of the day, it gets written to the ds.dat file or the ANSYS Classic input file. So that's what's required to create an extension. To have your extension, you were, well, it's a WBEX is the extension for it, but it's a compiled version of the XML and Python code. So that's something the user that's creating the extension will do. They'll compile it, so then they can give this file to anyone in the organization to use. And all the user would have to do is go on the project page, extension, install the extension, and then they should manage the extensions. Afterwards, then it'll pop up a little project page that says, what extensions do you want to use. and then the one you want to use. You open up mechanical, that functionality will be there that's related to that ACT extension. Now, there's licensing or anything required for that. Once you have that extension of it, you can use it. There's no licensing or anything required for that. There is a license required to build the extension, though, or essentially a license to compile the code XML and Python. Since it's compiled, you can give it to anyone, and there's no license required. So the license is for you to create that file to give to other people. And then, as a part, you also get technical support for ACT and the documentation, the developer's guide, and the API guide for how to create your own extension. So that in terms of how it's licensed and set up. If you look at what access to right now, anyone that can get onto the ANSYS customer portal can download all these different ACT extensions, and you can try them out for yourself. Now, so just some of the different ones are already up there. You can create some, say, acoustics in mechanical, so that's a pretty full one. There's piezoelectric capabilities. Actually, Workbench Elastine extension might be the most extensive extension out there. It lets you set up, solve, and post-process the Elastine simulation, which is the Elastine export, which just writes out the .k file. This you can actually do some more things and read it and the results in there. But other ones, FE info, change materials, do some 2D morphing of nodes and submodeling. So there's a bunch of ones already up there, and hopefully they'll just continue to grow in the future as more people submit extensions to that. Some extensions are not there, but they're ones that ANSYS has developed. This allows you to do component mode synthesis in mechanical. So you can create super elements from different bodies, and then behind the scenes it does a generation, use, and expansion path for those super elements. So the rather involved, call it a premium extension, but this was one developed for a particular customer. Example of the type of extension that was developed for a customer was a manager. So you can get an idea of different things that can be done with this type of customization. So say you have some component on the top right here. You want to analyze this thing, but they want to also include in some other parts that would make up the full assembly. So you build a separate mechanical simulation part. You mesh it. You have all the materials. You have all the contacts. Everything's set up in this project. Maybe this was even solved. Everything was all set up in here. You can use this assembly manager to save, write out this mechanical simulation of just this part, and you can choose to then import that mechanical simulation into your existing project in here. So all the mesh, contacts, material properties, loads, everything that used to be in this standalone simulation is now added to the existing project. And then you could add, some other, maybe some component, and you just put it in a different location, whatever the case is. So this is combining different mechanical databases all in one. That's a nice, very powerful one. But again, something that was developed by ANSYS for a particular customer. So just quickly, if you have any ACT extensions that you think you'd like to develop, or you just have questions about, whatever it is, we've developed extensions here. So we have expertise with that. If you want to discuss any questions or opportunity for creating an extension, please feel free to contact us, and then we can get you out, or at least have some discussions about it to do. So let's take another quick poll. Let me open it up here. Okay. So do you think? So hopefully the poll popped up. ACT would enable more engineers at your company to use Workbench. So just go ahead and answer that question. Just kind of see what we'll think of ACT. hopefully bridge a lot of the gaps between what's already in mechanical versus what you might need. So just kind of get a feel for that would help. So looks like pretty much a minute answer. I'll wait just a little bit longer here. And I think that's going out. So I'll close the poll, share the results with you. It looks like, yeah, it's kind of split. Maybe you're unsure if that would help or not. Fair enough. And some, if it would help to get more to using Workbench, that's great. If that's the case, like I said, AT can certainly help bridge the gap between the functionality that you'd like to have in there, what's actually already in there. So now see some of these different extensions in action. The example that I saw or showed you, really doing this behind the scenes, or let's say this example, a customer wants to always apply some type of win based on some standard that they have. Right, they're doing this. This is something that's not already existing in the code, and it would be nice to always have this feature available. So you can make an extension to do this. And behind that extension, you have a bunch of different constants and equations that come up with the win that gets applied to the model. Also prone to errors, maybe, getting all this stuff right. So I certainly don't want all the users to be able to do this every time they need this. So you create your own ACT extension to do this. In this case, it's the wind load that shows up here. So when I click this button, it inserts it into the entry. So when we hit on this, we need to fill in some data, no different than any other object. Mechanical. So we apply that wind loading to bunch of faces there. One of the things is that you can see units are associated with these different inputs. Right? This isn't something that it's a command block. You could certainly do this with a command block, but if you change the units to a different system and it's all that, the command no longer matches up. So this keeps track of all that. It'll do the conversion for you. You can put little drop downs in here. Whatever you need to do for that boundary condition. We can go and some model. We already have some in there, and then you could see the result of wind load in terms of just looking at the deformation that's on here. So you can see it makes it very easy to build in some function that wasn't there previously. So one example, another example is right here, where this a nonlinear analysis that was run. This is down. You have some time history down here. So the results already available in terms of grabbing out contact status, pressure. You can get some things in here initially, but what if they get say what was the contact stiffness through the different through here? Well, that's not something you could pull out here without beta options or something. You can extension do that. Another one here is non-info. Insert this into the tree, and this is a post-processing object. So here we can which contact we want to get some information from. So this contact pair in there, and then we can do that one. Say what's the normal stiffness, maximum normal stiffness for all those different iterations. And then here this charts it up and see all the sub-steps and then the normal stiffness here. So once the part's in contact, you can see the stiffness associated with that and how it changes through that. And maybe, I don't know, you put in number of elements in contact in the normal direction. So you can see here, that's the number of elements. So then at the end, we get about 5 elements in contact. That can track up a bunch of different information in here. Be a little bit more difficult to get out, or maybe isn't available at all. So that is another example. I have the post-processing one. And then is this FE info. example is accessing information in the GUI. So we wanted to select some elements. Well, that's something you can do in here. You can select nodes, make components of those, but maybe find out elements, let's say 1 through 20, are in the model. So we can, goes in here. Oh no. Zoom in here. You can see that it plots up the elements in here, them, so the element numbers, and we also have the nodes number in here. You can plot elements, you can grab query numbers, and there's a bunch of different things that is available in here. That makes it nice and easy to say your solution converged, field converged because of some element distorted. Well, then you can look up where element is located in the model. So, that's something that's available for manipulation or accessing information out of the mechanical GUI. Let's look at our example. We ran this 2D thermal analysis. We have some temperature distribution on this model. And then we take this temperature distribution and map it onto a 3D model. So then if we build a 3D model, so this 3D model that I want to apply that 2D temperature distribution on. So do that with this submodeling extension here. There's one for temperature, one for displacements. So insert this temperature extension. Then when we select bodies that we want to apply this temperature mapping to, we need to give it the file, the result file, 2D analysis, and say that the submodeling is going to be from 2D to 3D, and then also some tabular information here. So there's 2 load steps in this structural problem. What temperature do we want to map in from the thermal result file? So you can see pop up little tables, different things, that little drop downs. There's a lot of things you can do with the extension. So then we can go and solve this analysis with structural loads, but then we put on a user-defined result item for the temperatures and see what the temperature looked like. So it took the 2D temperature and then just mapped it around the circumference here. It might look a little different if this was actually a 3D thermal analysis, but it gets you maybe a quick approximation to what that might be. Let's say we looked at stress, we find the stress in this hole is some value, and see that there's a fairly coarse mesh around there. So maybe want to, without having to rerun this entire model, just submodel this local region in here. So then we can add and use the submodeling extension for displacement. So we build a model of just this localized region. We have a much fine mesh on here where we have some ones near the surface. And we apply this submodeling for displacement to grid mapping. And click the 2 faces here. That's going to get that mapping 3D to 3D. It could also be 2D to 3D, 3D to 3D, cell to solid. There's a bunch of different options for that, but we'll map placements from that previous structural analysis of the result file onto here. And then we also just grab the temperatures that were in that last example I showed, the 3D temperature distribution, 3D to 3D, or then 2D to 3D from that original model too, whatever you like to do. And then run this analysis and see that you have a much higher stress at this location. So illustrating that this modeling technique be done with an ACT extension. That's certainly the only way that it can be done. It really makes it nice, so everyone that's using this extension can just have that option in the inline tree. So it makes it very easy for users to be able to seamlessly add in some additional capability. So back here, that is it for the presentation.